Mill operation without our technology. The mill is first operated in manual mode. An ore feed size disturbance is introduced to the circuit. The ore size is effectively reduced. A finer ore size distribution results in a higher grinding rate, and the load in the mill starts To reverse this trend, the operator decreases the mill speed set point to slow the mill down. This slows down the discharge rate and leads to the mill load increasing. The discharge rate The decreasing discharge rate also means less material is entering the mill discharge sump, and the level in the sump starts dropping. To prevent the sump from running empty, the operator decreases the cyclone feed pump set point. From running empty, this action causes the cyclone pressure to drop. The level in the sump is still decreasing, but since the cyclone pressure is at the minimum, the operator increases the mill discharge sump water instead to try and reverse the decreasing level in the sump. Discharge sump water instead to try and reverse the decreasing level in the sump. The mill load is also still decreasing, and he increases the mill feed rate. The actions to the cyclone feed pump and discharge sump water were too big, and now the sump level is increasing. The operator increases the cyclone feed pump flow set point. The operator increases the mill load is also increasing too fast because the actions were too big. The operator cuts the mill feed tonnage. Now the mill load and discharge sump level are both increasing rapidly and heading for disaster. The operator checks the time and sees that it is almost lunchtime. He puts the real-time control and optimization solution in autopilot. He puts the real-time control and optimization solution in autopilot. The technology increases the mill feed rate and mill speed to reach the optimum mill load and sump level targets that maximizes throughput and mill efficiency, reduce energy requirements for the same throughput. And mill efficiency, reduce energy requirements for the same throughput. The mill stabilizes, and a new ore feed size disturbance is introduced. This time, it is an increase in the ore size distribution, leading to the mill load increasing. The RTC&O changes the mill speed and feed to reject the disturbance. The actions taken by the technology to reject the disturbance does not affect the sump level, as it did in manual operation, leading to a consistent cyclone pressure. Leading to a consistent cyclone pressure. The operator returns from lunch and finds the mill stable and running at the optimum operating point. He concludes that this technology is amazing and decides to never switch it off again. Amazing and decides to never switch it off again.